You trust OAuth to log into hundreds of apps, but in 2012, the guy who built it called his own protocol a road to hell. When you click Sign In with Google, your browser redirects to Google's authorization server. Google authenticates you, then sends back an authorization code. Your app trades that code for an access token, then uses the token to fetch your profile. That access token is a JWT, 3-base, 64 encoded chunks separated by dots. The header declares the signing algorithm. The payload holds your user ID and claims. The signature proves Google issued it. 65 to 70% of enterprise APIs now use OAuth or JWT, and 99% of those organizations had API security incidents last year. So how did we get here? OAuth began in November 2006 when Blaine Cook at Twitter needed OpenID support. The 1.0 final draft shipped October 3, 2007. OAuth 1.0 became RFC 5849 in April 2010. But developers hated OAuth 1. Every request required HMAC SHA-1 signatures, timestamp validation, and nonce tracking. The spec was 76 pages of cryptographic requirements. So in early 2010, a working group proposed OAuth wrap, bearer tokens instead of cryptographic proof. No signatures, no timestamps, just a simple string that grants access to whoever holds it. The lead editor, Aaron Hammer, watched the spec grow with enterprise consulting opportunities. He said, OAuth 2 became, quote, more complex, less interoperable, and most importantly, less secure. Hammer removed his name from the spec on July 28, 2012. Dick Hart took over as editor. 3 months later, in October 2012, OAuth 2.0 published as RFC 6749. Today, over 14,600 companies run OAuth worldwide. 6,600 of them are in the United States. Google eliminated password authentication on May 1, 2025. Microsoft kills basic authentication April 30, 2026. OAuth authentication now completes in 4 seconds versus 6 seconds for password methods. That 50% speed improvement drove mass adoption despite the security warnings. OAuth 1, but what did we actually build? The OAuth 2.0 specification itself is not broken. What attackers exploit are legitimate by design features of the protocol. They use trusted infrastructure exactly as the spec intended. In August 2025, attackers stole OAuth refresh tokens from Salesloft's Drift chatbot integration. Those tokens had no expiration date. Between August 9th and 17th, the attackers replayed them across 700 organizations. No passwords stolen. No malware deployed. The attackers systematically queried and exported large volumes of records. They operated for 10 days straight, using nothing but legitimate OAuth tokens. The victims included Cloudflare, Google itself, PagerDuty, Palo Alto Networks, Proofpoint, SpyCloud, Tanium, and Zscaler. On August 20th, Salesforce revoked every single Drift OAuth token and removed the app from the AppExchange marketplace. The vast majority of API attacks abuse legitimate authenticated sessions rather than bypassing authentication altogether. That is the core problem. OAuth tokens work exactly as designed, even in the hands of attackers. Now let's talk about JWT. RFC 7519, the JWT specification published in May 2015, defines a header field called ALG for algorithm. RS-256 means RSA signature. HS-256 means HMAC. And then there's none. When algorithm equals none, the JWT is not signed at all. If a library implicitly accepts this algorithm, the attacker can forge any token they want, and the server treats it as valid by default. Security consultant Tim McLean reported this vulnerability in JWT libraries back in 2015. It is now 2026. 6 new CVEs for algorithm confusion were filed this year alone. Another vector is algorithm substitution. The attacker changes RS-256 to HS-256. Some libraries will then validate the RSA signature using the public key as the HMAC shared secret. The impact? Remote code execution, privilege escalation, full account takeover. CVE 2025-46-92 exposed cloud platforms. CVE 2025-31-44 bypassed authentication libraries. CVE 2025-27-371 enabled remote code execution. And it keeps working because the vulnerability isn't in the spec. It's in how developers implement validation. The spec allows algorithm none. Developers forget to explicitly reject it. And the attack surface just got bigger. By 2026, autonomous AI agents hold their own OAuth tokens. They run continuously, make autonomous decisions about data access, and create integrations without human oversight. Most identity governance tooling was built for humans, not machines. Machine identities multiply faster than human accounts, persist longer, and audit trails don't capture intent. You can see that an AI agent accessed customer data, but you can't see why it made that decision. Meanwhile, OAuth phishing has become a subscription service. Toolkits like Squarefish, Squarefish 2, Graphish, Tycoon, and ODX automate complex OAuth sequences and come with support channels and regular updates. Proofpoint tracked multiple clusters exploiting device code flows against Microsoft 365 tenants. In autumn 2025, these kits drove half of all device code traffic. RH-ISAC counted attacks touching 900 tenants and 3,000 user accounts. Datadog reported attackers weaponizing Microsoft Copilot Studio agents for stealth exfiltration. Graphish even offers a subscription service with customer support. OAuth exploitation is now a productized business. So what's the fix? OAuth 2.1 is in late-stage IETF draft as of November 2024. Draft IETF OAuth v2115 hasn't been published as a final RFC yet, but it mandates 2 critical changes. First, it removes the implicit flow entirely. Second, it mandates PKCE, pronounced PKCE, for all client types. PKCE stands for Proof Key for Code Exchange, published as RFC 7636 in September 2015. PKCE works by generating a random code verifier before the OAuth flow starts. You hash it into a code challenge and send that with the authorization request. When you exchange the code for a token, you prove you have the original verifier. No one can intercept the code and use it. That prevents authorization code interception. But PKCE doesn't solve token theft, algorithm confusion, refresh token persistence, or the supply chain attacks we just saw. It only hardens one step of the flow. The IETF is developing GNAP, the Grant Negotiation and Authorization Protocol, as OAuth's successor. It uses key-bound tokens and a transactional model that addresses architectural flaws OAuth 2 inherited. OAuth 2 treats tokens like bearer instruments. Whoever holds the token owns it. GNAP binds tokens cryptographically to the client key. Stealing the token alone isn't enough. You also need the private key. So here's the payoff from the hook. Aaron Hammer was right. OAuth 2.0 traded security for adoption. It removed cryptographic requirements to make the protocol simpler and faster. And it worked. 14,000 companies bet their authentication on a protocol the designer publicly called fundamentally broken. We got speed, simplicity, and universal adoption. The cost was a decade of breaches that used the system exactly as designed. 700 organizations compromised through one integration. 6 JWT CVEs in 2025 for a vulnerability documented in 2015. Thanks for watching. Go rotate your refresh tokens. I'll be here pronouncing JWT as Jot.